Hi everybody, I'm just going to do a very quick video just to explain the basics of interfaces and how they can be quite a powerful tool to use in implementing our projects. So I'm just going to do a very basic example, okay, just to try to give an idea of what's going on. Okay, so I'm going to create a new project. Interface example. So it might be good just to follow along with the example and just try and figure out what's going on with it, okay? So, create my new project. Fine, so I'm going to create an entry point. So, new class, I'm going to call it main. Oops, I'm going to call it main. Public static, void main string args, entry point. Absolutely fine. Okay, excellent. So, what I'm going to do is just a very simple example, just to try and let us get an idea of the concepts that we're dealing with here, okay? So what we're going to end up with is a number of different objects that all have common or similar attributes. They're common, but they're different, so they're going to be different classes in that we will instantiate objects of different types. But to some degree they're quite similar, and in certain circumstances we'll want to draw on these similarities in that it'll allow us to manipulate the content that we're operating on and to be able to treat them as similar grouped objects even though they're not of the same type. And this is where interfaces come in for us, okay? So the first thing I'm going to do is I'm going to create a new class. File, new class. I'm going to create a new cat. So I'm going to just draw on some animal examples for us, okay? So create a cat, okay? And I'm going to say that the cat has a name. Sugar. Public string name. Okay. And the cat has a name. And equally that the cat can talk. Public void, we'll call it talk. So when this method is called, the cat will talk. And we're going to say, just out to console, system.out. So the cat meows. Fine, so I'm going to save my friend. Save. Okay, so there's my cat. So I'm going to come back, and I think this is great. So I'm going to say cat1 is equals to new cat. That's absolutely fine. We said that the cat should have a name, so maybe in the constructor, so in the cats, we'll give the cat a constructor. Public cat, we'll pass in a string, name, and we'll say this dot name, which is the class attribute of name, is equals to the one that's passed in via the constructor, which is name. And that's absolutely fine. So we save our friend so that when we're instantiating our cat, we give the cat a name. So the cat name is Dodger. Okay, fine. So there is cat1.dodger. So cat1.talk. There's the method that's available for the cat. So let's save that. And I run, and the cat tells us meow. Okay, absolutely fine. So, and we might even just improve this. So the cat says meow, and maybe we'll improve this a little bit. And we'll say that name string concatenate Whoops. Okay, I get it. Okay. Name said meow, so we'll know who's talking to us. So let's come back and run again. So this should tell us that Dodger said meow. Absolutely fine. So that's brilliant. So from want to create another instance of our cat friend, we can have cat2 is equals to Felix. We save, and then we can say cat2.talk, and Dodger said meow, and Felix said meow. So absolutely fine. So we're going to create a lot of these objects. So where can we store them? So I want to store these into an array list. And later on, I'm going to loop through this and get all of the cats to talk, okay? So I'm going to say array list of type cat. And I'm going to call it my list. So that's the variable name for it, is equals to new array list. And I'm going to say cat. Okay, and we have to fix our imports. So let's get java.util into action. Okay, so there's my array list. So let's say I create cat1, so I won't get him to talk yet. Create cat1, and then I can add him to my structure with my list dot add cat1. Perfect. Now, so add the new cat1 object to my array list structure. Fine. My list dot add cat2. Add the second cat in. Perfect. Love it. So save that. Now we said we were going to loop through these and try and display out some of our types, or get the cats to say hello. So presume here we have 20 cats here. We've only 2, but it's fine. 4. Int I equals to 0. I is less than my list dot size of the array structure, and I plus plus. Okay, so get a for loop into action. Why a for loop? Because we know exactly how many times we want to do something. It's controlled via the size of the array list, which is got using the dot size method, and we increment using I. Fine. So inside here, I'm going to say cat temp. So a temporary cat is equals to my list dot get at a particular index, which is going to be I, and that's fine. Now I can go for temp dot talk. Okay, so inside my loop, I instantiate a temporary cat, and I'm retrieving the object that's stored in a given position in my array list, and returning it and storing it in a variable called temp, which is of type cat. So the get method, so for the first iteration it'll be get of 0. For the second iteration it'll be get of 1, and so on and so forth. Once I have the object, I'm telling the object to perform its task, which is temp.talk. So fine, save, run. Dodger said meow, Felix said meow, perfect. And that's great. So here we sit with our array list, and it's great. Now, someone has come to us and said, we need to store some different information. So this time, we'd like to be able to store some dogs. So we said, look, storing dogs is easy. I'll just create a new dog class. So file, new class, type name, I'll call it dog, finish. What? A dog has a name, so tab, public, string, name. A dog can talk to, so it's public void talk. What are we going to go for? System dot out dot print line. I'm going to say, what does a dog say? Woof. Cool. So dog has a name, so we better set this. So we'll use a constructor for this. Public dog, and into this we will pass string name, and inside here this dot name, which is the class variable, is equals to name, which is the one passed in via the constructor. We may as well make this a little bit more meaningful. We'll say whoever said it, name said, careful, name, string concatenate, space said. I suppose we could just join these together, but no difference. Said, whatever. Okay. So there's my dog. So I come back to my main method. So after my cat, I'm going to go for dog. Dog 1 is equals to new dog. We'll call our dog Ricky. Okay, perfect. Now let's see, similar to our previous one, I can go for dog 1 dot talk. Perfect, love this. This is great. So there's my new dog. Everyone's happy. So Ricky said woof. That's my dog. Excellent. The Dodger said meow, which is the cat. And Felix said meow, which is the cat, which is great. Now, this is super, but I don't want him out here on his own, so I just want to go for my list dot add, and I'm going to pass in dog 1. Perfect. Ooh, okay. So it's not liking this. It's saying the method add cat in the type array list cat is not applicable for the arguments dog. I'm like, look, you know, like, we're dealing with animals here, so all animals are similar in that they just have different attributes. They, or you know, what's similar to them in that they can all breathe, they can all talk, they can all do great things, walk, whatever, okay? But we're a little bit stuck here now in that the cat and the dog, I can't store them in the same container. Now, obviously I could change my friend here, cat, to be back of type object, but that's still not going to solve our problems. So what can I do? So I wonder, would an interface help us here, okay? So the objects are quite similar, and the functionality or the tasks that the objects can perform is quite similar. The methods are there. The animals can just talk. We have a talk method. Each animal has a name. So what can we do with this? So what happens? Let's see if I'm going to add an interface in. I think an interface might help her. So I'm going to go File, New, Interface. There we have it. And I'm going to call it iAnimal. Okay. So we're dealing with animals. And public interface iAnimal. And it's going to say public. So the common method, there'll be a good few of these, but we're just going to keep this one simple. I'm going to say that an animal can talk. There's probably a lot of other attributes associated with the animal, and we could list these here as functionality via methods. So I'm just going to keep this one simple and say that our animals can just talk. So public void talk. Now, nice. So there's very simple interface, public void talk. Now, the cat and the dog don't seem to want to play anymore. They're not playing ball. So what can I do with this? So I'm going to say that my array list is going to solve this problem. So I'm going to come back and fix my problems first. So the cat will follow the rules of the interface. It implements I-A-N-I-M-A-L, implements I-animal. No one's giving out, we're fine. Dog implements I-A-N-I-M-A-L. That's fine. So both classes are following the rules of the interface. No one's giving out because we already have implemented public void talk. Cat, public void talk, following the rules of the interface, public void talk. So any object that's of type I-animal, we're guaranteed that it has implemented the talk method. And that's what we want from our interface. So I'm going to come back here, and my array list is going to be of type I-A-N-I-M-A-L, I-animal. And we're going to say it is of type, oh sugar, I-A-N-I-M-A-L. And that's fine. So we can see here that the cat or dog, that's absolutely fine. Cannot convert I-animal to cat. Okay, so our for loop is giving out. So what happens if I change my cat to type? Save. So now, no one's displaying out here. I've instantiated two cats and a dog and added them to my array list structure. Inside the loop, the type is of I-animal, temp is equals to mylist.get the object in a given position in my array structure. Then I tell the object to talk. Whatever it's going to say, let it say it. So save and run. Dodger said meow, Felix said meow, Ricky said woof. Absolutely fine. I have a cat and a dog, and I'm using an array list of type I-animal. Now, where the flexibility comes with this is that I can introduce a wide variety of different animal objects to the functionality that we have here, and it will still perform its task. It's not going to break anymore. So what else can I bring in? Well, I'm going to have to add a new class. So let's add a new type of animal and see what happens. So in Java project, oh no, sorry, Java class, what have we done? File, new, class, what will we add? I suppose we'd add a tiger. So we create a tiger. So the tiger will have a name, similar. So the structure of these will be similar. Now, okay, let's do it first and foremost. We're adding in a new animal. And to make sure that the animal, the new animal, which is our tiger, operates exactly as we expect it to, we ask the tiger to follow the rules of the interface. Public class tiger implements I-A-N-I-M-A-L. Okay, and there we said, so I'm going to save this, and you can see straight away that the class is already giving out. It's telling me that the type tiger must implement the inherited abstract method I-animal.talk. You're like, geez, you know, you're giving out already. Why? Well, we haven't implemented the method. What method? Well, this method, public void talk. You're following the rules of the interface called I-animal, and we must implement public void talk. If you look in here, we haven't implemented anything, and it's giving out. And that's exactly what we want. This is it. It's not letting us compile the project. We can't build or do whatever we want with it. We have to implement our method. So this is great. So let's just knock together our tiger, okay? Public void, or I don't know why I'm saying string. Public string name. I need a constructor. Public. What are we saying? Tiger. The tiger has a name. So when we're instantiating our tiger, this dot name is equals to name. Perfect. And then the last thing is public void talk. Keep the interface happy. I'm going to say system dot out dot println What are we going to say? That the tiger roars. Yeah, why not? We make it a little more meaningful. We'll say name, sugar name, string concatenate, said, space, string concatenate, everyone's happy, save, fine, back to main, tiger, tiger1 is equals to new tiger. I don't know what I'm going to call the tiger. What will I call the tiger? We'll call him Timmy. Timmy the tiger. Fine. So create the new tiger. Everyone's happy with him. We add the tiger to the list. mylist.add. Careful that. Tiger1. And we're done. So we add the tiger to the list. Now, I've added a new type of object. I've instantiated the object. I've added the object to the array list structure. I don't want to have to change anything. So when I run this, I expect that the cats talk, the dogs talk, and the tiger talks, and that's it. And there we go. So Dodger, Felix, Ricky, and there's Timmy the tiger, and he's roaring. So what we're trying to do is to make our solution as loosely coupled as possible, in that if any other objects are added to the system that are similar in operation to what we have, and or we want them to be able to work with what's already there, in that maybe they're being stored, maybe they're offering some functionality to the system, etc., etc. This is going to allow us to deal with similar types of objects through interfaces. And how are we dealing with the similar? The similar, which is the functionality, has been defined in our interfaces. So this is where the similar takes place. We tell all of our objects to follow the rules of the interface. And then when we come back to our code base, we're dealing with objects of type interface, which is iAnimal, and everybody plays ball, okay? So the only thing we can access through the dot notation is, so where are we going? iAnimal. So if I was dealing with a cat, the only thing I can get cat to do is cat1 dot, and then off we go. So what we've access to, that's the cat there, okay? So that's normal for the cat. So you can see here, this is the difference between the two. I want you to see this, okay? So cat1 dot, see the way I have cat1 dot name here, which is absolutely perfect. That's because I'm dealing with an object of type cat. If I'm dealing with an object that's of type iAnimal, so if I'm dealing with temp here, so if I go temp dot, you see I don't have name anymore. The only thing I have is access to the methods. And that's the contract that we're actually dealing with. This is the common functionality. Whatever's on offer, functionality-wise, is defined in the interface. And when we're dealing with an object of type interface, we can only access the methods, not the public data variables or attributes that are associated with the class as well. So that's quite important to see, okay? So this is the first little video I'm going to do for this, just to explain the kind of strength or the basics of our interfaces, in that I can use different types of objects and manipulate them as I please, in that any object that has been stored within this particular structure, it's of type iAnimal. So the guarantee will be that any object in this particular structure has the talk method, and that's what I expect, and I expect no less. So this is why this is quite a a tidy solution for what we have here, okay? So guys, I hope you found this helpful. If you have any questions, please let me know. Thanks.